What if you could step into a reality where every choice you ever made had a different outcome? A place where you accepted that job offer you turned down, or where you took that left turn instead of a right, creating an entirely different life path. This isn't just a daydream or a plot from a science fiction film. It's the profound and staggering possibility at the heart of parallel universes. For generations, the idea of other realities existing alongside our own has captivated scientists, philosophers, and storytellers, pushing the boundaries of what we believe is possible. Today, we're going to explore the ultimate frontier of this concept, the very first instance of travel to a parallel universe. Imagine being the first person, the first consciousness, to cross that invisible threshold and witness a cosmos that is both familiar and utterly alien. It's a journey that challenges the very fabric of reality as we know it, and we are about to uncover 30 groundbreaking theories that attempt to explain how such a monumental event could occur. Think about the sheer scale of human curiosity for a moment. It's this innate drive that has propelled us from discovering fire to landing on the moon. We have always looked at the horizon and wondered what lies beyond. Now we are staring into the deepest questions of existence itself, peering into the cosmic mirror and asking if our reflection is truly alone. This video is an invitation to join that adventure, to stretch your imagination to its absolute limits. We'll navigate through concepts that sound like they're pulled from the most ambitious fiction, from quantum tunneling through the fabric of spacetime to harnessing the energy of cosmic strings. We're not just talking about a simple hop to another dimension. We're exploring the theoretical mechanisms, the potential first contact scenarios, and the earth-shattering implications of proving, once and for all, that our universe is just one page in an infinite cosmic library. So get ready to have everything you think you know about reality challenged. We're about to dive into a realm of cosmic possibilities, where the laws of physics as we understand them might be merely suggestions, and where the idea of a single, linear history is replaced by a sprawling tapestry of alternate nows. This is a journey built on the cutting edge of theoretical physics and boundless human imagination, a fun and slightly mind-bending exploration of what could be the greatest discovery in the entire history of our species. Let's begin this incredible exploration together and uncover the 30 theories about the universe's first parallel universe travel. Our journey begins not with a roaring engine or a flashy portal, but with the quietest, most fundamental whisper in all of existence. The first theory proposes that the inaugural journey to a parallel universe was a complete accident, a cosmic fluke born from the bizarre rules that govern the subatomic world. This is the theory of the quantum tunneling pioneer. In our everyday experience, if you throw a ball at a wall, it bounces back, but in the quantum realm, particles don't play by those rules. Thanks to the strange principle of quantum uncertainty, there's a tiny but non-zero probability that a particle can simply disappear from one side of an energy barrier and instantly reappear on the other. It's as if it didn't go over or around the wall, but simply found a temporary tunnel straight through it. Now, imagine that the fabric of spacetime itself isn't perfectly smooth. At the tiniest conceivable scales, it's believed to be a seething, bubbling foam of virtual particles popping in and out of existence. Within this quantum foam, microscopic cracks and flaws could spontaneously form tiny, transient gateways to other realms in the multiverse. The theory suggests that one of these random tunneling events didn't just move a particle a tiny distance within our universe. Instead, a single, lucky subatomic particle, or perhaps a simple, hardy organism like a tardigrade, encountered one of these fleeting spacetime flaws and tunneled out entirely, becoming the very first traveler to another reality. The implications of this are staggering to consider. This wasn't a mission planned by a brilliant scientist or a feat of advanced engineering. It was a random act of nature, a one in a Googleplex cosmic lottery ticket that was cashed in by complete chance. Think of it like the first single-celled organism washing up on a primordial beach, unaware it was the vanguard for all life to come. This accidental pioneer, whether a particle or a microbe, would have crossed a threshold without any intention, without any consciousness, and without any way to return. Its journey would have been instantaneous and, from our perspective, utterly undetectable. One moment it's here, the next it's simply gone, its signature lost to our universe forever. But in that new universe, its arrival might have set off a chain of events with consequences we can barely fathom. If it was a particle, its sudden appearance could have subtly altered quantum states, potentially changing the outcome of a future chemical reaction billions of years down the line. If it was a living organism, it might have seeded an entirely new tree of life in a reality that was previously sterile, becoming the Adam or Eve of a whole new world. This single, tiny, accidental event could have sent ripples through the cosmic pond, altering the destiny of an entire universe simply because one thing was in the wrong place at the right time. While the first traveler might have been a random accident of nature, the second theory takes us to the complete opposite end of the spectrum, the possibility of deliberate, intelligent design. This is the concept of the ancient cosmic engineer. Picture a civilization so profoundly advanced that it arose when our own solar system was still a swirling cloud of cosmic dust. Given the universe is nearly 14 billion years old, it is statistically almost a certainty that other intelligent life evolved long before we did. This civilization wouldn't just have advanced computers and space travel. They would have mastered the very forces of the cosmos, manipulating gravity and space-time as easily as we flip a light switch. Their ultimate achievement, the pinnacle of their scientific endeavor, would have been the construction of a stable gateway, a permanent bridge to another universe. Their motivations for such an unimaginable project could have been as varied as our own reasons for exploring the deep sea or launching probes to other planets. Perhaps their home star was reaching the end of its life, and they sought a new cosmos to colonize, a fresh start in a reality untouched by their universe's eventual heat death. Or maybe they were driven by an insatiable thirst for knowledge, a desire to see what laws of physics operated in a different cosmic domain, to meet other forms of intelligence, or simply to answer the fundamental question, are we alone in the totality of existence? This idea offers a fascinating potential resolution to the famous Fermi paradox, which asks, where is everybody? If the universe is so vast and old, why haven't we encountered any evidence of other civilizations? The answer proposed by this theory is simple yet profound. They aren't here because they've moved on. They graduated from our universe. They achieved the ultimate form of exploration, stepping out of our cosmic neighborhood entirely and into the infinite possibilities of the multiverse. We might be like an isolated tribe in a vast, unexplored jungle, completely unaware that a sophisticated interstellar highway was built right over our heads billions of years ago. The evidence of their passage might still be out there, hidden in plain sight. Imagine our most powerful telescopes one day detecting an utterly unnatural structure, a perfect geometric shape defying orbital mechanics, or a subtle, persistent energy signature with no conceivable natural source located in the deep void between galaxies. These wouldn't be merely alien artifacts. They would be the ruins of a cosmic port, the dormant machinery of a gateway used by the universe's first intentional travelers. They wouldn't have left behind simple messages or probes. They left behind the very infrastructure for interstellar, or rather inter-universal travel, a technology so advanced that we might not even recognize it as technology at all. The first traveler, then, wasn't a lucky particle, but a deliberate envoy from a race of gods, embarking on a planned expedition into the great unknown that lies beyond our own reality. But what if the first crossing wasn't an accident or an act of engineering, but an intrinsic part of creation itself? This brings us to our third theory, which takes us back to the very beginning of everything. We're talking about the singularity spillover. To understand this, we need to picture the wider cosmos not as a single, isolated universe, but as a vast, bubbling foam of universe bubbles, each one inflating from its own Big Bang event within a greater background multiverse. Now imagine the moment of our own Big Bang. For a fleeting instant, all the energy and matter that would ever exist in our cosmos was compressed into an unimaginably hot, dense point, a singularity. The prevailing cosmological theory suggests that a fraction of a second after this moment, our universe underwent a period of incredibly rapid expansion known as inflation, blowing up from a quantum speck to a macroscopic size in less than the blink of an eye. The singularity spillover theory proposes that this process wasn't perfectly clean. The sheer, violent energy of that initial inflation could have caused a kind of cosmic splash. Think of it like a single, massive raindrop falling into a still puddle. The impact sends a main splash upward, that's our universe, but it also creates smaller, secondary droplets that jump out and land nearby. In this cosmic scenario, our entire universe, or perhaps a small fragment of its primordial energy, was that secondary droplet. The first act of parallel universe travel wasn't a journey at all. It was a cosmic birth defect, a natural spillover from the birthing process of another parent universe. This idea fundamentally reshapes our origin story. We wouldn't be the original universe, but an offshoot, a branch on an infinite cosmic tree. Our fundamental constants, the strength of gravity, the mass of an electron, all the numbers that make our reality stable and life-permitting, might simply be the ones that happen to get frozen into place during our particular splash event. A neighboring universe bubble, born from a different splash at the same cosmic event, could have entirely different physical laws, perhaps where gravity is repulsive or atoms can't even form. The first traveler, in this case, wasn't a person or even a particle, but the very quantum field that would eventually condense into all the galaxies, stars, and planets we see today. It was a transfer of potential, a piece of one reality calibrating itself into a new, independent existence. This theory elegantly sidesteps the question of engineering or chance. It frames multiverse travel not as something that needs to be invented, but as something that happened naturally at the moment of Genesis. We are all, in a very literal sense, the descendants of that initial spillover, living in a universe that has been traveling away from its point of origin since the first moment of time. Now let's turn inward to the most complex and mysterious frontier we know, the human mind itself. This fourth theory ventures beyond physics and into the realm of metaphysics, proposing that the very first traveler to a parallel universe wasn't a physical body or a random particle, but a conscious mind. This is the concept of the consciousness gateway. For centuries, mystics and philosophers have pondered the nature of thought, asking if consciousness is merely a byproduct of the brain's electrical activity or something more fundamental, perhaps a fundamental property of the cosmos itself. This theory leans into the latter idea, suggesting that a consciousness that becomes sufficiently aware and focused could learn to untether itself from its physical vessel and project its awareness across the dimensional barriers that separate one reality from another. It's a notion that resonates with ancient practices like astral projection or deep meditative states, where individuals report a sensation of leaving their bodies and perceiving realities beyond our own. What if these aren't just hallucinations or dreams, but the first clumsy, unintentional steps of a mind learning to navigate the multiverse? This idea directly tackles what scientists call the hard problem of consciousness, the question of why and how we have subjective, first-person experiences at all. If consciousness is indeed a fundamental aspect of the universe, like space and time, then it might not be bound by the same physical laws that govern matter and energy. A mind that has mastered its own existence could, in theory, manipulate the underlying information field of reality, essentially rewriting the local rules enough to slip into a neighboring cosmic domain. Imagine a future where advanced meditation techniques, neurotechnological interfaces, or even a spontaneous psychic event allows a single, incredibly focused consciousness to achieve this breakthrough. The journey wouldn't involve rockets or wormholes, but a profound shift in perception, a feeling of the self expanding beyond all boundaries, seeing the intricate tapestry of cause and effect not as a single thread, but as an infinite web of possibilities. The first traveler would experience alternate versions of their own life, witness historical events that never happened here, and interact with echoes of people they know, all through the lens of pure awareness. The implications of this are, to put it mildly, trippy. It suggests that every time we daydream about a different choice we could have made, or have a vivid, lifelike dream of an unfamiliar place, we might be inadvertently brushing up against the edges of these other realities. The first successful crossing would be the ultimate act of introspection, a journey not into outer space, but into what we might call inner space. The traveler wouldn't bring back physical artifacts or photographs. They would return with memories, feelings, and knowledge from a world with a completely different history. Proving such an event would be nearly impossible with our current scientific tools, as it leaves no physical trace. The only evidence would be the traveler's own testimony, a profound and unshakable knowing that would challenge everything we accept as real. This theory places the power for the greatest discovery not in the hands of engineers with massive machines, but potentially in the mind of a monk in deep meditation, a visionary artist, or a child with an unexplainable gift. The ultimate proof that the universe's most powerful gateway might have been hidden within us all along. Now, let's shift our focus from the infinitesimally small to the astronomically massive, from the quantum foam to the darkest objects in the cosmos. Our fifth theory presents a scenario of terrifying and irreversible finality, the black hole one-way ticket. This hypothesis dares to suggest that the first journey to a parallel universe was not a gentle slide or a conscious projection, but a violent, one-way trip initiated by something or someone falling into a black hole. We often picture black holes as cosmic vacuum cleaners, relentless destroyers from which nothing, not even light, can escape. But what if their role is far more complex? Within the framework of Einstein's theory of general relativity, the mathematics describing a black hole's interior can be extended to form what is known as an Einstein-Rosen bridge, a theoretical tunnel or wormhole connecting two distant points in spacetime. While most of these bridges are thought to be unstable, collapsing instantly, some physicists speculate that the unfathomable conditions at the heart of a sufficiently large, rotating black hole, known as a Kerr black hole, could potentially support a stable bridge. This bridge wouldn't lead to another place in our universe, but could instead exit into an entirely different universe altogether, a separate branch of the cosmic tree. The journey through such a gateway, however, would be the ultimate test of survival. Any traveler approaching a black hole would first face the gruesome process of spaghettification. The gravitational pull at your feet would be exponentially stronger than the pull at your head, stretching your body into a long, thin stream of atoms like a piece of cosmic taffy. For a stellar mass black hole, this would happen well before crossing the event horizon, the point of no return. But for a supermassive black hole like the one at the center of our galaxy, the tidal forces are much gentler. It's theoretically possible to cross the event horizon of such a beast before being torn apart. Imagine a future interstellar probe designed to study a supermassive black hole up close, losing power or suffering a guidance malfunction. Drawn inexorably by gravity, it silently slips past the event horizon. From our perspective outside, we would see the probe slow down, its light red shifted into oblivion until it seemingly freezes and fades from existence. But from the probe's perspective, if it could survive, it would continue its fall into the unknown interior. The fate of this first traveler is the greatest mystery of this theory. Would it emerge, battered but intact, into the light of a foreign sun in a new universe? Or would the journey through the wormhole itself be lethal, a chaotic passage through regions of extreme gravity and spatial distortion that would shred any complex structure into its fundamental particles? Perhaps the traveler wouldn't emerge as a physical object at all, but as a spray of raw information, a cosmic message in a bottle containing the data pattern of what once was, ready to be reassembled by the laws of a new reality. This theory carries a profound and solemn weight. It frames the first contact with a parallel universe not as a triumphant discovery, but as a catastrophic accident or a tragic sacrifice. The first pioneer might not have been seeking a new world at all, but simply a victim of cosmic circumstance whose destruction in our reality became their genesis in another. It's a stark reminder that the universe's greatest wonders are often guarded by its most formidable dangers, and that the key to unlocking the multiverse might lie in braving the one place from which there is supposed to be no return. Following that harrowing journey through a black hole, we arrive at a theory that turns the entire search inward once again, but this time into the mysterious landscape of our own sleeping minds. This sixth proposal is known as the Dreamweaver's Passage, and it dares to suggest that the very first crossing into a parallel universe didn't require a massive machine or a cosmic catastrophe, but simply a person falling into a particularly potent and vivid dream. Every night as we sleep, our brains construct entire worlds from fragments of memory, emotion, and pure imagination. These are not just random firings of neurons, they are full sensory experiences that feel utterly real while we are inside them. Neurologically, when we dream, the parts of our brain responsible for logic and critical thinking are subdued, while the regions that handle sensory processing and emotion are lit up with activity. It's as if the brain's normal reality testing mechanism is temporarily switched off, allowing for a state of pure, unbound perception. The Dreamweaver theory posits that in this uniquely open and malleable state of consciousness, the barrier between a personal, internal dream and a shared, external reality could, under the right circumstances, become dangerously thin. A lucid dreamer, someone who becomes aware they are dreaming and can sometimes exert control, might not just be shaping their own subconscious, but might be inadvertently tuning their mind's frequency to perceive, and perhaps even step into, a reality that already exists in parallel to our own. Imagine the experience of this first traveler. It wouldn't begin with a roar of engines, but with a gentle descent into sleep. This individual, perhaps a natural lucid dreamer or someone trained in deep meditative practices, enters a dream that feels different from any other. The details are hyper-real, the sense of presence overwhelming. They might find themselves walking through a city where the architecture is familiar yet impossibly twisted, with stairways leading to floating islands and clocks that tell the time in colors instead of numbers. The sky above might be a swirling vortex of nebulas and constellations they've never seen, casting an ethereal, otherworldly light. This isn't the fuzzy, disjointed logic of a normal dream. It feels like exploring a real, physical place with its own consistent, albeit bizarre, set of rules. The theory suggests that in this heightened state, the dreamer's consciousness doesn't just simulate this world. It actually resonates with it, locking onto a parallel dimension where these surreal landscapes are the permanent, solid reality. The passage isn't a tunnel through space, but a synchronization of mind and cosmos, a momentary bridge built from pure awareness and the brain's unique ability to bypass its own perceptual filters. The evidence for such an event would be as elusive as a dream upon waking. The traveler would eventually awaken, likely with a jolt, back in their own bed. They would be left with nothing but a powerful, visceral memory, a recollection so intense and detailed that it would haunt them for the rest of their life. They might possess knowledge they have no way of knowing, like the layout of a city that doesn't exist or the solution to a scientific problem that hasn't been posed yet. To anyone else, their story would sound like a fascinating but ultimately unverifiable dream. This theory challenges our most fundamental definitions of what is real and what is illusion. It proposes that every night, as we close our eyes, we might be skimming the surface of an infinite ocean of alternate realities, usually protected by the cognitive dissonance of the sleeping brain. The first successful traveler was simply the one whose mind, in a perfect storm of neurological conditions and cosmic chance, slipped through the veil completely, if only for a single night. Their journey would leave no physical trace, no wormhole for others to follow, just the profound and unshakable conviction that the universe next door is closer than we ever imagined, waiting just behind our eyelids. What if the key to stepping sideways into a new reality wasn't a spatial gateway at all, but a temporal one? Our seventh theory weaves together two of science fiction's most enduring concepts, proposing that the first journey to a parallel universe was a direct result of a catastrophic failure in time travel. The classic thought experiment, the grandfather paradox, illustrates the problem perfectly. If you were to travel back in time and prevent your own grandfather from meeting your grandmother, you would create an insoluble logical contradiction. You would never have been born to go back in time in the first place. So, how could such an event possibly occur? The solution proposed by many physicists is that the universe simply cannot tolerate a paradox. The moment your actions are about to create an impossible logical loop, reality itself forks in the road. One timeline continues as it always did, where your grandfather lives and you are eventually born. But a new, parallel timeline instantly branches off, one in which your grandfather died young and you were never born. In this new universe, you aren't a native, you are an anomaly, a visitor from another stream of history. You didn't travel through space to get there, you literally talked reality into splitting in two to accommodate your presence. This branching mechanism offers a potential escape from another bewildering temporal puzzle, the bootstrap paradox. Imagine a time traveler who brings a copy of Beethoven's Fifth Symphony back to the 18th century and gives it to a young Beethoven, who then simply copies it out and publishes it as his own. The music was never truly composed by anyone, it just exists in a closed loop with no discernible origin. Now consider a more volatile scenario. What if a time traveler's very presence in the past, even with the best intentions, introduces information or technology that is too disruptive? The fabric of cause and effect might strain to the breaking point, unable to neatly reintegrate this foreign element without creating countless inconsistencies. At that critical moment of tension, the theory suggests reality's failsafe engages. Instead of allowing the timeline to collapse into nonsense, it gently, or perhaps violently, peels the disruptive event away, placing it into its own newly created parallel universe where the traveler's actions become the new foundational history. The first parallel universe traveler, then, might have been a time explorer who stepped into their machine expecting to see dinosaurs, only to inadvertently trigger a reality divergence event. They arrive in a world that looks like the past, but is in fact a brand new universe where their arrival is the first and most important historical event. Visualize this not as a sleek portal opening, but as an immense, intricate clockwork of gears representing our single, linear timeline. Each tick of the clock is a moment in history, each gear turning in perfect, synchronized harmony. Now a foreign element, the time traveler, is introduced into this delicate mechanism. The gears grind, they stutter, and a crack forms along the mainspring. In a flash of brilliant light, the entire assembly fractures, with one set of gears continuing to spin as always, while a new, identical set branches away, its teeth now meshing in a slightly different pattern, telling a new kind of time from that moment forward. The traveler is now stranded in this new branch, a living paradox who can never return to the timeline they once called home because, in a very real sense, they have become the reason it can no longer exist in a singular form. Their journey was a one-way trip from a universe of certainty to a universe of their own making, a permanent immigrant to a reality born from their own impossible actions. This theory profoundly connects the concepts of time and parallel worlds, suggesting that the multiverse might be constantly expanding not just through spatial inflation, but through the countless forks in the road created by every decision that could have gone another way and every paradox that was too powerful to be contained. While we often picture advanced technology or cosmic phenomena as the key to other realities, our eighth theory suggests the most elegant gateway might be one that evolved naturally. This is the concept of the biological evolutionary leap, which dares to imagine that the very first traveler to a parallel universe wasn't a scientist or an astronaut, but an animal, a creature that developed the ability to perceive and step into adjacent realities as a fundamental biological trait, much like a bird flies or a fish swims. Picture a world vastly different from our own, a planet where extinction-level events, supervolcanoes, asteroid impacts, or abrupt climate shifts occur not once every few million years, but with the regularity of the changing seasons. On such a volatile world, the relentless pressure of natural selection wouldn't just favor the strongest or the fastest. It would reward a capability far more profound, the ability to simply step out of the way. Over countless generations, a species on the brink might have begun to develop a unique organ, a complex biological structure capable of detecting the subtle quantum vibrations of the multiverse. At first, this might have manifested as a faint, instinctual unease, a primal urge to migrate moments before a catastrophe struck. But over millennia, this trait would have been refined into a conscious, controllable ability to phase shift their entire physical form into a neighboring reality, escaping certain doom by moving sideways into a safer version of their own world. This notion opens up a fascinating possibility: convergent evolution across the multiverse. Just as the streamlined shape of a dolphin, a shark, and an extinct ichthyos are all evolved independently for efficient swimming in water, the ability to navigate dimensions could be a biological solution that arises repeatedly under similar extreme pressures. We could imagine a whole taxonomy of such creatures across countless universes. Perhaps in one reality, a massive, browsing herbivore developed a cranial organ that allows it to flicker in and out of visibility, confusing predators. In another, a species of intelligent life might use this ability not just for survival, but for exploration, becoming the natural-born astronauts of the cosmos. The biological mechanisms for such a feat are mind-bending to consider. The creature might possess a specialized organ, something we could call a dimensional gland, woven from exotic matter and superconductive neurons. This gland wouldn't process chemicals, but information, reading the underlying quantum code of local spacetime and rewriting it just enough to create a temporary personal gateway. The process of shifting could be metabolically intense, requiring immense energy reserves, and might be accompanied by a brilliant bioluminescent display as the creature's body harnesses its own internal energy to tear a hole in reality itself. You wouldn't see a mechanical portal, you'd witness a living being glowing with otherworldly light, its form becoming hazy and insubstantial before vanishing with a soft pop of displaced air, leaving nothing behind but the faint scent of ozone and the echo of a reality that has been gently breached. Envisioning the appearance of such a being is a thrilling exercise. Concept art for this creature would likely show a form that is both alien and strangely purposeful. Its most prominent feature might be a large, complex crest or frill on its head, not for display but housing the intricate fractal-like folds of its dimensional gland. Its eyes could be massive, capable of perceiving not just visible light, but the quantum spin of particles, allowing it to literally see the seams between realities as shimmering, aurora-like curtains in the air. Its skin might be a shifting tapestry of colors and patterns, not for camouflage in our world, but as a side effect of its body constantly interacting with the quantum fields around it. Its limbs might be powerful, built for stability during the disorienting moment of transition. When it prepares to shift, this biological marvel might go through a dramatic transformation. Its crest would illuminate with complex, swirling patterns of light, its body humming with vibrational energy as it gathers the necessary power. Then, in a flash that is felt more than seen, it would simply step through the fabric of space, arriving in a nearly identical version of its home forest or plain, one where the volcano did not erupt or the asteroid missed the planet. This creature wouldn't be using technology to travel. It would be embodying the journey, its very biology a testament to the incredible, adaptive power of life when pushed to the absolute limit. Its existence would prove that the greatest secrets of the cosmos are not always found in metal and machinery, but can be encoded in flesh and blood, waiting for the right conditions to awaken. Shifting our perspective from the biological to the cosmic, we arrive at a theory that leverages the very scars of creation. Theory number 9 takes us to the cosmic string surfer. To understand this, we have to journey back to the universe's first, searing moments after the Big Bang. As the newborn cosmos expanded and cooled, physicists theorize that it may have undergone a series of profound phase transitions, much like steam condensing into water. And just as freezing water can trap air bubbles, these cosmic phase transitions might have trapped flaws in the very structure of spacetime itself. These flaws are known as cosmic strings, hypothetical, unimaginably thin filaments, thinner than a single atom but stretching across the entire universe. They are not made of matter but are pure wrinkles in the fabric of reality, and they possess staggering density. A single inch of a cosmic string could outweigh an entire mountain range, warping space-time and gravity around them in profound ways. The surfer theory proposes an audacious method of travel. Picture a future civilization that has not only detected one of these cosmic strings, but has developed the technology to approach it. Their vessel wouldn't use conventional rockets. It would be a gravity-shielded craft designed to withstand the intense tidal forces. The plan wouldn't be to cross the string, but to ride it. Because these strings are under immense tension, they are theorized to whip through the cosmos at incredible speeds, often close to the speed of light. The idea is that the extreme gravitational curvature around the string could create a natural warp drive, bending spacetime in such a way that traveling alongside it allows for effective faster-than-light travel without violating known physics. But the most radical part of the theory suggests that at certain points, perhaps where two strings cross or where a string intersects with a black hole, the spacetime distortion could become so severe that it pinches off a connection to another universe entirely. A skilled pilot, a true cosmic surfer, could use this moment to steer their craft directly into the breach, catching a wave on a filament of primordial energy and riding it right out of our cosmic ocean and into the next. The visuals of such a journey would be beyond anything Hollywood could conjure. From a distance, the cosmic string might be invisible, detectable only by the way it lenses the light from galaxies behind it, creating a telltale double image in the void. As the surfer's ship draws nearer, space itself would begin to visibly ripple and distort. Stars would smear into long, brilliant lines, and the fabric of the cosmos would appear to be stretched taut like the skin of a drum. Upon engaging with the string, the ship would be enveloped in a maelstrom of gravitational and quantum energies. The view from the cockpit wouldn't be of stars, but of a tunnel of pure, chaotic light, a kaleidoscope of every color in the spectrum, and some that don't exist in our reality, all swirling around the central, dark thread of the string itself. The surfer wouldn't be navigating by sight, but by feel, reading the gravitational currents and quantum fluctuations as a sailor reads the waves and the wind. The final transition would be a silent, unimaginable flash. One moment, the ship is racing through a corridor of tortured spacetime. The next, it emerges into the calm of a new cosmos, the cosmic string receding behind it like a fishing line cast back into its home waters, leaving the traveler alone to behold the alien constellations of a universe never before seen by human eyes. The idea that our minds might be the ultimate vessel for cosmic exploration leads us to our 10th theory, a concept that pushes the boundaries of consciousness itself. This is the psionic-resonance breakthrough, a hypothesis suggesting the first journey was not a physical relocation, but a mental retuning, achieved by a being whose psychic energy became so focused it could literally harmonize with the vibrational frequency of another reality. The core principle here is that everything in the universe, from the smallest atom to the largest galaxy, has a fundamental vibrational signature. Our own reality resonates at a specific frequency, a sort of cosmic hum that underpins all of existence. This theory posits that a mind of sufficient power and clarity could learn to perceive these background frequencies and, through immense will, alter its own psychic resonance to match that of a parallel cosmos. The transition wouldn't involve stepping through a portal, but rather a gradual phasing where the traveler's consciousness and perhaps their physical form becomes less substantial in our universe and more tangible in the next, all while maintaining a continuous thread of self-awareness. This notion finds a fascinating, if controversial, echo in real-world scientific explorations. Researchers studying the hard problem of consciousness have long pondered its fundamental nature. Is it merely an emergent property of neural computation, or could it be something more intrinsic to the cosmos, a fundamental field akin to gravity? Experiments in neurophysics have shown that human brainwaves can exhibit strange coherence and even subtle entanglement, effects that classical physics struggles to explain. Furthermore, the cosmic microwave background radiation, the lingering afterglow of the Big Bang, fills the entire universe with a faint, low-frequency hum. The psionic-resonance theory daringly suggests a connection between these two phenomena, that a mind operating at peak, unified consciousness could somehow sync its own neural oscillations with this primordial cosmic signal, using it as a carrier wave to broadcast its awareness beyond the confines of our local spacetime. The visuals for such an event would be both beautiful and eerie. We might see the individual enveloped in a shimmering aura of light, not generated from an external source, but emanating from their own body as their bioenergy aligns with the target universe. The air around them would begin to waver like heat haze on a summer day, but instead of distorting the background, it would begin to reveal a second, superimposed image, the landscape of the parallel world bleeding through like a double-exposed photograph. Their physical form might become translucent, a ghostly outline against the merging realities, as the very atoms of their body learn to vibrate in harmony with a new set of physical laws. Imagine the experience of this first psionic pioneer. It would begin not with a countdown, but with a deep, meditative silence. The individual, having trained for years or perhaps possessing a natural, unprecedented gift, would enter a trance-like state of absolute focus. Their brainwave activity, if we could measure it, would show a stunning synchronization, with all disparate regions of the brain locking into a single, coherent frequency pattern. To an outside observer, they would appear to be in a deep sleep, but internally, their awareness would be expanding at an exponential rate. They would feel their sense of self stretching beyond their physical body, perceiving the room not with their eyes, but as a complex web of energy and information. Then they would begin to hear it, a new note in the symphony of the cosmos, a frequency slightly off-key from our own universe's background hum. With an act of pure will, they would begin to adjust their own mental resonance, tuning themselves to this foreign signal. The sensation would be one of profound reorientation, as if every cell in their body was being gently remapped. The familiar world would fade, not to blackness, but to a state of potential, and from that potential, a new reality would crystallize around them. They wouldn't arrive with a jolt, but would simply become aware that they were now somewhere else, their journey complete not through movement, but through a fundamental act of attunement, proving that the greatest distances can be crossed without ever taking a single step. But what if the map to other universes has been hiding in the dark all along, woven into the very fabric of the cosmos we cannot see? Our 11th theory introduces the dark matter navigator, a concept that pivots from manipulating the ordinary to mastering the invisible. For decades, scientists have known that the matter we can see, The stars, planets, and galaxies accounts for a pitifully small fraction of what must actually be out there. The rest, the overwhelming majority, is a mysterious substance known as dark matter. It doesn't emit, absorb, or reflect light, making it completely invisible to our telescopes, yet its gravitational pull is the cosmic glue holding galaxies together, preventing them from flying apart as they spin. This theory proposes that the first travelers weren't just brilliant physicists. They were the first to truly understand that dark matter isn't just passive scaffolding. It is an active, dynamic medium that permeates all of space, and its profound gravitational influence could be the ultimate tool for engineering stable gateways to other realities. The core idea here is one of cosmic origami. Think of spacetime as a vast, flat sheet. Normally, folding this sheet to bring two distant points together would require an unimaginable amount of energy, the kind found only in the most violent cosmic events. But dark matter offers a potential shortcut. Because it interacts gravitationally but not electromagnetically, it can clump and form structures that ordinary matter simply passes through. A sufficiently advanced civilization could learn to manipulate these dark matter structures, gathering and compressing them to create specific, intense gravitational lenses. By carefully shaping these lenses, they could, in theory, fold spacetime in a controlled and stable manner, creating a wormhole that doesn't instantly collapse under its own gravity. The navigator's vessel wouldn't punch its way through reality. It would gently coax spacetime to fold around it, using the dark matter's own gravity to hold the doorway open just long enough to pass through. It's the difference between blasting a hole through a mountain and politely asking the mountain to form a tunnel for you. Envisioning the technology for such a feat is a thrilling challenge. The ship itself would be a masterpiece of gravitational engineering, likely equipped with emitters that don't project energy, but rather project precise gravitational fields to attract and sculpt the surrounding dark matter. Instead of a traditional sail catching solar winds, this ship would deploy a dark matter sail, a vast, intricately woven mesh designed to interact directly with the invisible medium. As it activates, we wouldn't see a flash of light, but rather a profound distortion in the starfield behind it. The stars would smear and warp, bending around a central point of absolute blackness as the dark matter is drawn into a precise configuration. The portal wouldn't be a window showing another place. It would be a perfect sphere of nothingness, a void so complete it seems to suck the very light and sound from the surrounding space. The ship, guided by unimaginably complex calculations, would then drift into this sphere of curated nothing, its dark matter sail billowing in cosmic winds we cannot feel, and simply vanish. From the outside, the transition would be silent and eerie. From the inside, the crew might experience a moment of weightless, senseless calm before emerging into a new universe, having used the hidden 95% of reality as both their fuel and their gateway. Now, let's explore a theory that questions the very nature of our existence, suggesting that the first journey wasn't a physical voyage at all, but a software error in the cosmic operating system. This is the simulated universe glitch, a concept rooted in the compelling and controversial simulation hypothesis. The core idea is that our universe, with all its galaxies, stars, and conscious life, isn't the base level of reality, but an incredibly advanced digital construct, a simulation running on a computer of unimaginable power, perhaps built by a civilization eons ahead of us. Within such a simulation, everything from the force of gravity to the sensation of love would be governed by a complex, self-consistent code. And like any complex program, no matter how well designed, it would inevitably contain bugs. This theory proposes that the first successful crossing into a parallel universe occurred when an entity, either a conscious being inside the simulation or a user from the outside, accidentally or intentionally triggered a critical flaw in this underlying code, creating a temporary backdoor into another instance of the simulation, or even out into the reality one level above our own. Imagine the moment of discovery. It wouldn't begin with a rocket launch, but with an anomaly, a persistent, unexplainable error in the fabric of perceived reality. A physicist running a particle collision experiment might witness results that blatantly violate the known laws of physics, with particles behaving in ways that are not just improbable, but logically impossible within our universe's rule set. Or an individual might experience a personal glitch, like seeing a building flicker in and out of existence for a split second, or hearing a low, persistent digital hum where there should be silence. These wouldn't be hallucinations, but literal cracks in the simulation's rendering engine, moments where the raw code underneath pokes through the immersive graphics of our world. The first traveler could have been a simulated consciousness who, through deep meditation, advanced technology, or sheer chance, learned to perceive these glitches and manipulate them. By focusing on a specific anomaly, they might have been able to force a buffer overflow or a memory leak in their local reality, causing the simulation to crash in a very specific, controlled way that dumped their conscious data stream not into oblivion, but into a neighboring server running a different version of the universe. The philosophical implications of this are enough to make your head spin. If this theory is true, it redefines the concept of a parallel universe. Another reality isn't a separate bubble in a cosmic foam. It's just another saved game file on the same cosmic hard drive, running with slightly different initial parameters. The traveler isn't moving through space, but being transferred between databases. This raises profound questions about identity and existence. If you are copied and pasted into a new simulation, are you still you? Is the original you deleted, or does it continue on in the home simulation? The very act of traveling could create a fork, leaving a copy behind and sending a new instance forward. Visuals for this transition would be starkly different from a wormhole or a psychic projection. We might see the traveler's environment begin to pixelate and tear, with cascading green lines of base code scrolling down like digital rain, revealing the sterile, mathematical architecture beneath our colorful illusion. Solid walls might become translucent, showing only wireframe models, and the sounds of the world would degrade into raw data streams and system error chimes. The final transition would feel less like a journey and more like a reboot, a moment of total sensory shutdown followed by the slow, sequential loading of a new world, as if the universe itself is booting up around them for the very first time. Moving from the invisible architecture of dark matter to a celestial phenomenon we can actually observe, our 13th theory proposes that the first gateway to a parallel universe was unlocked not by technology, but by the clockwork motion of the cosmos itself. This is the theory of the planetary alignment key. Imagine the gravitational field generated by a single planet. It's a gentle curve in the fabric of space-time, barely noticeable. But when multiple massive bodies, planets, moons, even the sun, slide into a perfect razor-straight line, their individual gravitational fields don't just add together. They can amplify and resonate, stacking up to create a temporary, focused lens of immense power. According to this idea, under the precise conditions of an ultra-rare grand alignment, this combined gravitational focus could become so intense that it pinches space-time, thinning the barrier between realities until a transient, natural portal briefly flickers into existence. It would be a doorway forged by pure orbital mechanics, a key that turns in the lock of the universe only once every few millennia, if at all. This concept finds a haunting echo in the myths and monuments of ancient civilizations across our world. The Maya meticulously tracked the movements of Venus, believing its cycles were tied to the fates of kings and empires. Structures like Stonehenge are famously aligned with solar and lunar events, suggesting our ancestors understood that celestial patterns held profound significance. What if these legends of world-ending events or ages of gods walking the earth were not mere metaphors, but fragmented cultural memories of a time when such an alignment occurred? Perhaps a previous, now lost human civilization witnessed the effects of a minor spacetime anomaly caused by a planetary syzygy, a strange shimmering in the air, a sudden temporal distortion, or even the brief, ghostly appearance of another landscape superimposed on their own. They wouldn't have had the physics to explain it, so they encoded the warning or the prophecy into their stories and aligned their greatest temples to the heavens, hoping to predict or perhaps even invoke the next occurrence of this cosmic event. Visualizing this celestial key turning is a breathtaking exercise. From a vantage point in deep space, we would see the planets of a solar system slowly, inexorably moving into a flawless line. First, the gas giants Jupiter and Saturn, their immense gravity beginning to warp the space between them. Then, the inner rocky worlds Mars, Earth, Venus, and Mercury slide into place with the Sun blazing at one end of this cosmic conga line. The combined gravitational pull wouldn't create a violent vortex, but something far more subtle and majestic. The starlight from the galaxy behind this alignment would begin to bend, not into a simple lens, but into a perfect, brilliant ring of warped light, an Einstein ring of unimaginable scale and precision. At the very center of this ring, where the gravitational focus is most intense, space-time would not just bend, it would thin to the point of transparency. A window would open, not showing a distant part of our own universe, but a view into a completely different cosmic landscape. We might see a nebula of impossible colors or a constellation of stars arranged in a pattern that has never existed in our night sky. This natural gateway, held open only for as long as the planets maintain their perfect alignment, would be a serene and silent invitation, a bridge built by the universe itself, waiting for someone or something to step across. The implications for a potential traveler are as dramatic as the visuals. This isn't a journey one could meticulously plan for years. It's an opportunity that presents itself for a fleeting moment, a cosmic slot that opens and closes according to a schedule written in the motions of worlds. A future society, having decoded ancient warnings and perfected astrophysical predictions, might position their vessel at the exact calculated point in space, waiting in tense silence as the planets drift into their critical formation. There would be no roaring engine to activate. The power is supplied entirely by the solar system. The ship would simply need to drift into the heart of the gravitational lens at the precise moment. The experience of crossing would likely be one of surreal calm. As the ship passes the threshold, the view of the aligned planets and the warped starlight would suddenly vanish, replaced by the uncharted vista of the new universe. Looking back, the traveler might see the same planetary alignment from the other side, a shimmering porthole already beginning to close as the celestial bodies continue their endless dance, severing the connection and leaving them truly and perhaps permanently in a new reality. But what if the very idea of a spaceship or a physical body is a limitation of our own biology? Our 14th theory invites us to shed our physical form entirely and consider a traveler of a completely different nature. This is the energy being migration, a concept where the first entities to cross the cosmic divide were non-corporeal beings of pure consciousness and energy, for whom moving between universes is as natural and instinctive as a fish swimming between different currents in a vast ocean. We often imagine life as requiring a carbon-based body, a vessel of flesh and bone, but the conditions for life could be infinitely more diverse. On a world orbiting a pulsar or deep within the plasma storms of a nebula, evolution might favor not solid forms, but organized patterns of energy beings that think in currents and perceive in frequencies. For such entities, the barrier between universes might not be a solid wall to be broken down, but a permeable membrane, a difference in density or vibrational state that they can simply flow through by adjusting their own energetic signature. Trying to imagine the perception of such a being is a profound challenge. They wouldn't see a star as a ball of fire, but as a complex symphony of gravitational waves, magnetic fields, and nuclear fusion frequencies. A planet wouldn't be a solid rock, but a slow, resonant hum of mass and chemistry. Their reality is one of pure physics experienced directly. A journey to a parallel universe for them wouldn't involve a dangerous voyage through a wormhole. It might feel more like a dolphin leaping from one layer of the ocean into another, a shift in pressure and temperature and light. They could perceive the multiverse as a shimmering, multi-layered energy field, with each universe glowing with its own distinct hue in a spectrum far beyond our visual comprehension. Their migration could be driven by forces we can barely grasp. Perhaps they follow gradients in the background energy of the cosmos, moving from universes that are growing cold and still to ones that are young and vibrant with energetic potential, much like birds migrating to warmer climates. The most fascinating implication of this theory is the possibility of an accidental guide. Imagine one of these energy beings flowing gracefully from its home reality into ours. It might not even be aware of our existence as discrete, solid life forms, just as we are mostly unaware of the complex bacterial ecosystems on our own skin. But its passage would leave a trace. As it transitions, its energy field would interact with our local spacetime, creating a temporary, shimmering corridor, a visible, beautiful distortion. To a human observer, this might look like a spontaneous, silent aurora blooming in deep space, a river of impossibly vibrant light weaving through the void without a discernible source. Or for a lucky astronaut on a spacewalk, it might appear as a sudden, breathtaking curtain of luminescence that parts for just a moment, revealing a glimpse of an alien starscape beyond before vanishing. This wouldn't be a constructed gateway, it would be the wake of a cosmic traveler, a path shown not out of intention but simply by the act of its passing. The visuals for such an event would be abstract and awe-inspiring. Picture the inky blackness of space suddenly blossoming with a fluid, living light. Not the hard, geometric lines of a sci-fi stargate, but something more organic and ethereal, great, flowing ribbons of energy in colors that don't have names, pulsing with a soft, internal rhythm. These ribbons would twist and merge, not like fire, but like liquid silk or intelligent plasma, carving a temporary, luminous pathway through the cosmos. At the heart of this display, there might be a brighter, more concentrated nexus of light, the being itself, not as a defined shape, but as a focal point of immense sentient energy. The act of crossing would be a graceful, seamless flow, as the entire structure glides from one state of existence to another, leaving behind only a fading afterglow and the profound, paradigm-shattering realization for any who witnessed it that the universe is home to forms of life so advanced and so different from us that their daily commute involves traveling between realities. Now we arrive at a theory that is as terrifying in its implications as it is elegant in its physics. This is the vacuum-decay catalyst, a scenario where the first journey to a parallel universe was not an act of exploration, but one of sheer, desperate survival. To understand this, we need to think about the nature of our reality not as a fixed stage, but as a delicate and potentially unstable equilibrium. Physicists describe the universe as existing in a false vacuum. Imagine our cosmos is like a ball resting in a small dip on the side of a vast, steep mountain. The ball is stable for now, but it's not in the absolute lowest possible energy state that lies at the bottom of the mountain. Our universe's laws of physics, the strength of gravity, the mass of electrons, are all defined by this precarious position. The terrifying prospect of vacuum decay is that something, a random quantum fluctuation or a high-energy experiment, could nudge that ball over the edge. It would start to roll downhill, and as it did, it would release an immense amount of latent energy, fundamentally changing the landscape of reality itself. This release wouldn't be a slow process. It would trigger a bubble of true vacuum that would expand in all directions at the speed of light. This isn't a physical explosion of matter, but a wave of transformation, rewriting the very laws of physics as it goes. Inside this expanding sphere, atoms might cease to hold together, forces like electromagnetism could vanish, and the concept of matter as we know it would simply dissolve into a new, stable, and almost certainly lifeless state. There would be no warning for anyone in its path. One moment you exist in a universe with stars and planets, the next an invisible wall of cosmic reformatting is upon you, and everything you are is instantly and irrevocably erased from existence. Now picture a civilization that has reached the pinnacle of scientific understanding. They are the first to discover this existential threat, not as a theory, but as an imminent certainty. Their instruments detect the initial, microscopic nucleation of a true vacuum bubble somewhere in the depths of space. They have perhaps mere days or hours before this unstoppable wave of oblivion reaches them, a countdown to the end of their entire cosmic neighborhood. Their only conceivable escape is a gamble of unimaginable proportions. Having theorized about the multiverse, they would funnel every resource, every ounce of their technological might into a single, desperate project, opening a stable gateway to a parallel universe. This wouldn't be a carefully tested prototype. It would be a jury-rigged cosmic lifeboat activated under the shadow of an approaching doomsday. The visuals for this final exodus would be the most dramatic spectacle one could witness. As the vacuum decay bubble sweeps through their solar system, the stars in the sky don't just go out, they unravel. A sun might twist into impossible geometric shapes before dissolving into a shower of pure light, its very atomic structure being rewritten. Planets would not explode, but rather pixelate and flow away like sand in a tide, their matter derezzing into a featureless, glowing haze. The very color of space would change, shifting to a hue never before seen by living eyes as the new physics of the true vacuum establishes its domain. The civilization's last act would be to launch their ark, or perhaps their entire world if they had the power, through a violently fluctuating portal, hurling themselves into the unknown just as the wave of transformation washes over their launch site. They would be the ultimate refugees, the only survivors of a universe that effectively committed suicide, carrying with them the memories and knowledge of a reality that no longer exists. Their arrival in a new cosmos would be a bittersweet victory, a testament to their brilliance and a permanent reminder of the catastrophic price of their survival. They wouldn't be explorers, they would be ghosts from a dead universe, living proof that the cosmos itself can be a fragile and treacherous place, and that the greatest journey might be the one you take to escape the end of everything you've ever known. What if the stories our ancestors told around crackling fires, the epic legends carved into temple walls, and the sacred beliefs passed down through generations weren't just flights of fancy, but were instead the faded, distorted memories of actual events? Our 16th theory delves into this mesmerizing possibility, the mythological gateway. This idea suggests that countless ancient myths describing journeys to other worlds are not mere metaphors, but are the cultural fossils of genuine, accidental encounters with parallel universes. Long before we had the language of quantum physics or cosmology, humanity experienced inexplicable phenomena and did their best to explain them with the vocabulary they had: the language of gods, spirits, and magic. These tales, when re-examined through a modern lens, reveal startlingly consistent patterns that point towards transient, natural breaches in the fabric of reality. Consider the shimmering Bifrost Bridge of Norse mythology, a radiant, burning rainbow that connected the world of humans, Midgard, to the divine realm of Asgard. The myths describe it as a guarded pathway used only by the gods and state that its colors are formed from fire. Now, reinterpret that description with the eyes of a physicist. A stable, traversable wormhole or a region of intensely warped spacetime would likely be surrounded by tremendous energy, bending and scattering light into a brilliant prismatic display, a bridge of fire and light precisely as described. The guardianship of the god Heimdallr could be a mythological representation of the immense energy or specific conditions required to stabilize such a passage, making it inaccessible to ordinary people. Similarly, the rich tapestry of Aboriginal Australian Dreamtime speaks of a sacred, eternal time of creation when the world was soft, and the ancestral spirits moved between the physical world and a parallel spiritual dimension, shaping the landscape as they went. This dreaming isn't seen as a past event, but as a parallel reality that exists here and now, accessible through ritual, song, and altered states of consciousness. This bears a striking resemblance to the modern theory that consciousness itself might be the key to perceiving other dimensions, and that certain locations on Earth might possess natural, low-level dimensional instabilities. The folklore of the British Isles is particularly ripe with these potential clues. Stories of fairy rings, circles of mushrooms where one could be whisked away to the land of the Fae, where time flows differently, echo the concept of localized spacetime anomalies. A person stepping into such a ring might experience a brief crossover, spending what feels like a single night in a parallel world, only to return and find that decades have passed in their home reality, a classic trope of time dilation and relativistic effects. The visual representation for these mythological gateways could be breathtaking, a seamless blend of ancient artistry and cosmic spectacle. Imagine a depiction of the Bifrost not as a simple painted rainbow, but as a dynamic, fiery Einstein ring, warping the starfield around it, with spectral Viking longships seemingly made of starlight and flame sailing upon its structure. For a fairy ring, we could see a stone circle like Stonehenge, but at its center, the air shimmers not with heat, but with a portal showing a ghostly, superimposed landscape of an eternal twilight realm, with strange, elegant beings beckoning from just beyond the veil. These visuals would not mock the old beliefs, but honor them, presenting the myths as humanity's first, intuitive grasp of a cosmic truth it did not yet have the science to name. This theory forces us to reconsider the very nature of human history and the roots of our spiritual beliefs. It proposes that the shaman, the oracle, and the seer were not simply charlatans or dreamers, but individuals who were somehow more sensitive or accidentally exposed to these natural dimensional rifts. Their visions of other worlds, their communications with gods and spirits, could have been literal, first-hand accounts of parallel realities. The universal human fear of certain places, haunted forests, forbidden mountains, deep caves, might be a primal, instinctual recognition of these weak spots in reality, places where the barrier between worlds is thin and fragile. The first traveler, then, might not have been a scientist of the future, but a Celtic warrior who followed a will-o'-the wisp into a misty bog and never returned. A Japanese woodcutter who ascended a mystical mountain and descended into a different century, or an Aboriginal elder who, through ritual and song, walked consciously into the dreaming. Their journeys became legend not because they were invented, but because they were true, their stories surviving for millennia as the only way our ancestors could make sense of the greatest mystery they had ever encountered. Building on that terrifying escape from a dying universe, we encounter a theory that is perhaps the most personal and philosophically dizzying of them all, because it places the fate of the first traveler not in the hands of gods or machines, but in the very nature of their own consciousness. This is the theory of the quantum suicide or immortality passenger. To grasp this concept, we first have to dive into one of the most bizarre ideas in all of physics, the many worlds interpretation of quantum mechanics. This theory suggests that every time a quantum event occurs with multiple possible outcomes, the entire universe doesn't just pick one. It splits, branching off into a near infinite number of parallel realities, one for each possible result. A single radioactive atom either decays or it doesn't, and in that moment, reality duplicates, with one universe containing the decayed atom and another containing the stable one. Now take this principle and apply it to a life or death scenario in the most extreme way imaginable. This is the quantum suicide thought experiment. Picture a device that is triggered by the random decay of a single radioactive atom. Once per second, the device checks the atom. If the atom has decayed, the device fires a lethal weapon, instantly killing the person connected to it. If the atom has not decayed, the device does nothing, and the experiment continues for another second. From the perspective of any outside observer, this is a brutally efficient execution machine. The odds are astronomically high that within a few minutes, maybe an hour, the atom will decay and the person will be killed. The observer would see this happen and confirm that the individual is, sadly, dead. But from the perspective of the person inside the experiment, something entirely different unfolds. As long as the person is conscious to observe the result, they will only ever experience the outcomes where the atom did not decay. In every single reality where the atom decays, they die and cease to have a conscious experience. But in the branching realities where the atom remains stable, they remain alive and aware. From their first-person point of view, they would sit there second after second, minute after minute, and the gun would never fire. They would achieve a form of subjective immortality, not because they are invincible, but because their conscious experience is forever confined to the ever-narrowing stream of realities in which they continue to survive. Now, imagine this principle applied not to a morbid laboratory experiment, but to a genuine attempt at parallel universe travel. The theory of the quantum suicide passenger suggests that the very first traveler was an individual who willingly placed themselves in a situation of quantum uncertainty on a cosmic scale. Instead of a gun, the quantum trigger might be connected to an experimental device designed to tear a hole in space-time. The device is powered by an unpredictable quantum process, and there are only two possible outcomes. Either it successfully opens a stable gateway to another universe, or it creates a catastrophic feedback loop that completely obliterates the traveler and their entire laboratory in a flash of energy. From the outside, an observer would almost certainly witness the latter. The machine would fail and the traveler would be erased from our reality. But from the traveler's own subjective perspective, they would only ever experience the one reality in a near-infinite sea of failures where the machine worked perfectly. They would pull the lever, and instead of being vaporized, they would find themselves stepping through a shimmering portal into a new world. They wouldn't have traveled through a gateway so much as they would have been selectively filtered into the one reality among countless dead-end branches where a gateway existed. Their journey was not a physical relocation from one place to another, but a continuous, unbroken chain of conscious experience that only exists in the timeline where the impossible gamble paid off. The implications of this for our understanding of identity and consciousness are enough to shatter your sense of self. It introduces the chilling concept of anthropic filtering, the idea that we are not special, but rather, we can only find ourselves in a universe compatible with our existence as observers. This traveler's consciousness didn't leap across the multiverse. It was simply shed, like a snake shedding its skin, from all the versions of reality where it was extinguished, continuing its existence only along the path where survival was possible. This raises a profound and unsettling question. Are we all, in a sense, quantum immortality passengers? Every time we narrowly avoid a fatal accident or survive a potentially deadly illness, could it be that in countless other branches of reality, we did not? And our conscious experience is simply tethered to the one thread of the cosmic tapestry where we are still here to have that experience. For the first traveler, this wasn't a philosophical abstraction, it was a lived reality. They would arrive in the new universe with the absolute, unshakable knowledge that they had effectively committed suicide in an incalculable number of other realities, and that their continued existence was a statistical miracle of the most bizarre kind. They wouldn't be an explorer who boldly went where no one had gone before. They would be a ghost from a legion of dead selves, the sole survivor of their own personal apocalypse, carrying the existential weight of knowing that for them to be here, an infinity of other versions of them had to perish. Leaping from the existential puzzles of quantum immortality, we journey back to the very foundations of reality with our 18th theory, a concept rooted in the most fundamental process of creation. This is the symmetry breaking event, a hypothesis suggesting the first traveler didn't cross space, but crossed a decision point in the very laws of physics at the dawn of time. To understand this, we need to picture the universe in its first fleeting fractions of a second. It was an unimaginably hot, dense, and perfectly symmetrical state. Every force was unified and every particle was identical, existing in a kind of featureless cosmic soup. But this perfect symmetry was inherently unstable. As the universe expanded and cooled, it had to choose a more stable but less symmetrical state. This is similar to a pencil perfectly balanced on its tip. It can't stay that way forever. The slightest perturbation will cause it to fall, and it must choose one direction to fall in, breaking its initial rotational symmetry. In the cosmos, this falling process is known as spontaneous symmetry breaking, and it's the reason we have the distinct forces and varied particles we see today. The most famous example is the Higgs field, which fell into a specific value throughout our universe, granting mass to fundamental particles and making chemistry, planets, and life itself possible. This theory proposes a staggering possibility. What if the universe didn't break its symmetry in just one way? The mathematics of these transitions often allow for multiple, equally valid outcomes. Our cosmos chose one set of physical laws, but right beside us, in a sense, another newborn universe was choosing a different set. For a fleeting moment during this chaotic phase transition, the barrier between these two nascent realities might have been paper thin, a temporary confusion in the fabric of causality itself. The first traveler, then, could have been an entity, perhaps even a quantum fluctuation with a primitive form of awareness that was present at this critical juncture. As the cosmic dice were rolling, this traveler didn't get caught in the settling of a single universe. Instead, it found itself straddling the divide, its very existence becoming entangled with the moment of choice. As the symmetry broke and the two universes crystallized into their permanent, separate states, this pioneer was simply on the other side of the decision, forever isolated in a cosmos whose fundamental rules were now irrevocably different from its point of origin. The abstract visuals for such an event would be less about portals and more about the architecture of reality itself. We could imagine the scene not as a place, but as a vast, abstract canvas of pure, white potential. This is the symmetric state, a blank slate of infinite possibility. Then color begins to bleed in, but not uniformly. Two distinct color schemes start to emerge from the whiteness, like ink diffusing through water. One region might resolve into the cool blues and stable geometries that represent our universe's laws, a place where gravity is weak and atoms are stable. The adjacent region might shimmer into existence with fiery reds and impossible, non-Euclidean shapes, representing a universe where the nuclear forces are stronger, perhaps where atoms cannot form and matter is a perpetual plasma. The traveler would be depicted as a single, shimmering point of consciousness, hovering at the exact boundary where these two color fields are separating. As the division becomes permanent, the point is gently but inexorably drawn into the red-hued reality, the connection to the blue universe severing like a taut string snapping. There is no violent transition, only a quiet, fundamental redefinition of what is real for that one entity. Consider the profound implications of arriving in such a universe. The traveler wouldn't just find unfamiliar stars, they would find a cosmos where the rules of existence are alien. If the strong nuclear force were even slightly stronger, atomic nuclei might be unstable, preventing the long-lived stars necessary for life. If the electromagnetic force were weaker, chemical bonds might not form, making planets and complex molecules impossible. The traveler might arrive in a reality that is eternally dark, perpetually violent, or so serene and uniform that structure never emerges. Their very atomic composition, forged in our universe's specific laws, might be instantly untenable, dissolving into energy or reconfiguring into a form native to the new physics. This theory frames the first journey not as an act of exploration, but as an act of cosmic birth, an accidental emigration at the moment the multiverse was defining its own diversity. The traveler becomes a permanent, living relic of a road not taken, a witness to the incredible, random luck that gave our own reality the precise set of physical constants that allowed us to be here, wondering about it all. Now we venture into a theory that challenges our most basic perception of dimensions, suggesting that the solid, three-dimensional world we experience is nothing more than a magnificent illusion. This is the theory of the holographic principal escape, an idea born from the cutting edge of theoretical physics and black hole thermodynamics. The principle proposes a staggering truth about our cosmos, that all the information needed to describe our seemingly vast, three-dimensional universe, every galaxy, every planet, every human thought, is actually encoded on a distant, two-dimensional surface that surrounds us, like the information on a Blu-ray disc projecting a rich, immersive 3D movie. In this view, our reality is a kind of cosmic projection, a hologram of breathtaking complexity, and we are all living inside it. The first traveler, according to this theory, was not someone who built a ship or a portal, but a physicist who finally cracked the code. They discovered that by manipulating quantum information at a fundamental level, it was possible to, in a sense, step outside of the projection, moving from the immersive 3D movie we call reality and back into the 2D source code from which it is rendered. The mechanics of such an escape are almost incomprehensibly strange. It wouldn't involve moving through space as we know it, because space itself is part of the projection. Instead, the traveler would have to perform an act of what we can only call dimensional translation. Using a technology that manipulates quantum entanglement on a massive scale, they could theoretically cause their own informational pattern to decouple from the 3D projection and re-anchor itself to the underlying 2D boundary. Imagine the process not as a flight but as a gradual de-rendering. From an outside perspective, the traveler's body would begin to lose its depth. They wouldn't become transparent, but rather they would appear to flatten, as if reality itself was forgetting how to display them in 3 dimensions. The rich textures of their skin, the subtle shadows cast by their form, the sense of volume and mass, all of it would slowly simplify, condensing down into an impossibly complex, shimmering pattern of light and data etched onto a flat, dark surface. The world around them would undergo the same transformation, the stars and galaxies smearing into a brilliant, two-dimensional mural of cosmic information. For the traveler, the experience would be one of the most disorienting possible, a feeling of the entire universe turning inside out around them. Once existing as a pattern of information on this fundamental surface, the traveler would be in the ultimate position of power, the cosmic equivalent of a film editor sitting at a console. They would perceive our entire universe not as a space full of objects, but as a vast, interconnected data structure. From this vantage point, accessing a parallel universe becomes a question of file management. Our universe is one projected data set. A parallel universe is simply another one stored on the same cosmic hard drive. The journey would involve the traveler's conscious information pattern navigating this 2D landscape, locating the data boundary of an adjacent reality, and then instructing the cosmic projector, so to speak, to re-render them from that new source. They wouldn't travel to the other universe, they would be rebooted from it, their consciousness and physical form reconstructed according to its entirely different set of physical laws and historical data. The act of crossing is instantaneous from their perspective, a blink, and the flattening process reverses, but now they are solidifying into a world that is both eerily familiar and fundamentally alien, having used the architecture of reality itself as their gateway. Now let's dive into a concept that harnesses the most bizarre and well-documented phenomenon in all of physics, a principle so strange that even its discoverer, Albert Einstein, famously called it spooky action at a distance. This is the theory of the entanglement bridge, and it suggests that the key to unlocking the multiverse has been dancing in front of our eyes at the subatomic level all along. Quantum entanglement occurs when two particles, like photons or electrons, are created or interact in such a way that they become inextricably linked, their fates intertwined no matter how far apart they are separated in space. If you measure a property of one particle, such as its spin, you instantly know the corresponding property of its entangled partner, even if that partner is on the other side of the galaxy. This instantaneous connection seems to defy the cosmic speed limit of light, creating what appears to be a single, unified system that transcends physical distance. The theory proposes a monumental leap of engineering. What if we could entangle particles not just across vast distances within our own universe, but across the dimensional barrier itself? Imagine a team of physicists who discover a method to create a pair of entangled particles where one half of the pair exists in our reality, and the other half manifests in a parallel universe. This wouldn't be a random accident, but a deliberate act of cosmic sewing, stitching a thread of quantum information between two separate realms of existence. The first step would be to identify a natural, fleeting point of contact between universes, perhaps a microscopic quantum fluctuation similar to those we discussed earlier. At that precise moment, a specially designed apparatus would inject a stream of particles, forcing them to become entangled across the divide. One particle remains in our lab, while its twin winks into existence in a reality next door. This single subatomic bridge would be the proof of concept, the first tangible connection ever made. But a single thread is not a doorway. The true challenge and the core of this theory is the mind-boggling process of scaling this effect up from the quantum to the macroscopic. How do you go from two linked electrons to a tunnel big enough and stable enough for a person to walk through? The technological marvel required would be unlike anything we've ever conceived. It would likely involve a colossal machine, perhaps a ring-shaped accelerator of planetary scale, designed not to smash particles but to orchestrate them. Its purpose would be to create not one entangled pair, but trillions upon trillions of them, all synchronized and layered together. Each pair would act like a single quantum stitch in a vast, shimmering fabric. By meticulously aligning the quantum states of all these entangled pairs, the machine could theoretically weave these individual threads into a cohesive, stable structure, a bridge of pure information and energy that reinforces itself through quantum coherence. It would be like using countless invisible spider silk threads to sew a temporary, traversable archway between two realities. Visualizing the formation of this entanglement bridge would be a spectacle of subtle, ethereal beauty. It wouldn't begin with a violent explosion of energy, but with a quiet hum. In the center of the massive accelerator ring, the air would begin to shimmer, not with heat, but with a faint, ghostly light. At first, you would see only individual sparkling points, like a dusting of diamonds suspended in mid-air, each one a newly formed cross-universe entangled pair. Then, as the machine powers up, these points would begin to connect, drawing lines of shimmering, pearlescent light between them. These lines would weave and braid themselves into a complex, three-dimensional lattice, a tunnel of interlacing energy that seems to be made of solidified moonlight. The center of this lattice would darken, not into blackness, but into a profound transparency, a window that looks not into emptiness, but into a scene that is both familiar and utterly alien. You might see a duplicate of the laboratory itself, but with a different arrangement of equipment, or a sky outside the window filled with constellations you've never seen. The bridge itself would pulse with a soft, internal rhythm, a visual representation of the countless quantum connections holding it open, a fragile and breathtaking pathway built from the spookiest action in the universe. Picture a reality where the cosmos is not a silent, still void, but a vast and restless ocean, its surface constantly rippling with waves of unimaginable scale. These aren't waves of water, but waves of gravity itself, undulations in the very fabric of space-time, left over from the most violent birth cry imaginable, the Big Bang. These are primordial gravitational waves, and our 21st theory proposes that the first journey to a parallel universe was made by an advanced civilization that learned not just to detect these waves, but to literally ride them, using these cosmic swells as a surfboard to glide right out of our reality and into the next. The concept builds on our confirmed detection of gravitational waves from colliding black holes and neutron stars, but it takes that idea to its ultimate, breathtaking extreme. These cataclysmic events create mere ripples in the cosmic pond. The waves from the Big Bang would be the tsunamis, colossal surges of gravitational energy that have been propagating through the universe for nearly 14 billion years. An advanced species wouldn't see these as background noise. They would see them as the universe's most powerful and natural transportation system, a pre-existing network of energy highways etched into space-time itself. The technological mastery required for such a feat is almost beyond comprehension. First, this civilization would need the ability to map the gravitational cosmos with subatomic precision. They wouldn't just know that a wave was passing, they would need to know its exact amplitude, frequency, and vector, charting the complex interference patterns as these ancient waves wash over each other across the universe. Their vessel would be the pinnacle of gravitational engineering, a ship not designed for thrust but for resonance. Think of it less like a rocket and more like a tuning fork, built to vibrate in perfect harmony with a specific gravitational frequency. To catch the wave, the ship would need to position itself with incredible accuracy at a point where the space-time curvature is just beginning to steepen, like a surfer paddling to match the speed of an approaching ocean wave. Then, at the critical moment, they would engage what we could call a gravity sail, a field-generating device that doesn't push against anything, but instead creates a localized, counteracting gravitational field that allows the ship to grip the leading edge of the space-time distortion. The energy required to create and maintain this field, especially in the face of a primordial wave, would be on the scale of harnessing the total output of multiple stars, making this a technology for a truly cosmic civilization. The visuals for this journey would be a surreal and beautiful distortion of reality itself. From an external view, as the ship locks onto the gravitational wave, the space around it would begin to visibly warp. The starlight from behind the vessel wouldn't just twinkle, it would smear into long, brilliant lines curving around the ship as if it were a lens of incredible power. The ship itself might appear to stretch and compress rhythmically, harmonizing with the frequency of the wave it's riding. There would be no roaring engine. The only sound, if it could be heard, would be a deep, resonant hum, the vibration of space-time itself. As the wave peaks, the distortion becomes so severe that the universe behind the ship seems to fold away. The surfer isn't just moving fast, they are carried along on a crest of twisted geometry, a roller coaster of pure gravity. The transition point would be marked by a silent, blinding flash of distorted light as the gravitational energy reaches a critical threshold, thinning the barrier between universes to nothing. One moment, the ship is surfing a wave of warped starlight. The next, it effortlessly glides over the edge and into the calm waters of a new cosmic ocean, leaving the primordial swell of its home universe to continue its journey without them. This theory presents the first traveler not as a miner blasting through rock, but as a master sailor, reading the currents of the cosmos and using its own inherent energy to journey where no one has ever gone before. After riding the cosmic swells of gravitational waves, we now descend into one of the most profound and unsettling thought experiments ever conceived. This is the Boltzmann brain emergence, a theory that questions not only how the first traveler might have arrived, but the very nature of their own existence and memories. To understand this, we have to grapple with a concept from thermodynamics known as entropy, which is essentially a measure of disorder in a system. The universe overall tends from order to disorder, from a hot, dense, organized state to a cold, spread-out, random one. However, the same statistical mechanics that govern this process also allow for a bizarre possibility. Given enough time, random quantum fluctuations can, by pure chance, assemble particles into any configuration, no matter how complex. In a vast, eternally expanding and cooling universe, the probability that a random fluctuation could spontaneously form a fully formed, self-aware brain, complete with false memories of a past life, is not zero. In fact, over near infinite timescales, it becomes almost inevitable. This hypothetical entity is known as a Boltzmann brain. Now, apply this chilling principle to our search for the first traveler. Theory 22 suggests that the inaugural journey was not a crossing at all, but a spontaneous birth. The first traveler was a Boltzmann brain that simply fluctuated into existence within a parallel universe. Its very first moment of consciousness would not be one of birth or creation, but of apparent arrival. It would wake up with a fully formed, intricate set of memories detailing an entire life, a childhood, an education, a career in physics, perhaps even the memory of stepping into an experimental machine designed to open a gateway. Every sensory detail, every emotion, every thought that led it to this point would be a perfect, convincing fabrication, a phantom past generated by a random cosmic accident. From its own subjective perspective, it would have successfully traveled from its home universe to this new one. It would have a story, a mission, and a profound sense of self. But in reality, it simply began existing, its entire history and identity nothing more than a statistical fluke in the cold, quiet emptiness of a foreign cosmos. The philosophical implications of this are a waking nightmare for our understanding of self. It introduces the terrifying possibility that you cannot trust your own memories or your sense of a continuous life. How could you ever be certain that you are not a Boltzmann brain, having just popped into existence moments ago, complete with the false memory of reading this sentence? This theory doesn't just challenge how we travel, it challenges who we are. For this first traveler, the journey was an illusion, a pre-packaged narrative embedded in its consciousness at the moment of its spontaneous formation. Its mission to explore a parallel universe would be a fiction, yet it would pursue it with absolute conviction, completely unaware that it had no past and no origins. It would study the alien stars of its new home, believing itself to be a pioneer, when in fact it was merely a temporary, self-aware eddy in the cosmic tide of entropy, destined to dissolve back into the random chaos from which it came as quickly as it formed. This scenario also presents a grim resolution to the Fermi paradox. If the universe is so vast and old, why does it seem so empty? One answer could be that the vast majority of intelligent beings are not evolved biological entities, but transient Boltzmann brains flickering in and out of existence in the void, each one living out its brief, illusory life in complete isolation, utterly unaware of its own true nature. The cosmos wouldn't be filled with civilizations, it would be filled with solitary, self-deceived ghosts, each one a monument to the power of random chance over narrative and meaning. The first traveler in this context becomes the ultimate tragic figure, a being that believes it has achieved the greatest discovery in history, only to be, in reality, the most profound and lonely accident in the multiverse, a thought without a thinker, a story without an author, forever separated from any genuine past or future. Building on the idea of manipulating the very fabric of space-time, we arrive at a theory that is as elegant as it is profound, a concept that turns the cosmos into an art form. This is the theory of dimensional folding origami. To grasp this, we need to step back from our usual three-dimensional perspective and consider a truly mind-bending possibility, that our entire universe, with all its galaxies, stars, and planets, is not an infinite, empty box, but a three-dimensional membrane, a brain floating within a higher dimensional space, often called the bulk. Imagine our universe is not a vast, black expanse, but a single, impossibly vast, impossibly thin sheet of paper. This paper is everything we know and can perceive. Now, in the world of origami, a flat, two-dimensional sheet of paper can be folded to bring two distant points into direct contact, creating a beautiful and complex three-dimensional sculpture. This theory applies that same principle, but on a cosmic scale. A being or a technology capable of operating in these higher dimensions wouldn't need to travel the long way across our three-dimensional sheet. It could simply reach down from the bulk, grasp our universe brain, and gently fold it, bringing a point in a distant galaxy, or even a point in a completely separate universe, right next to another, creating a temporary bridge between them. This isn't about warping space from within like a wormhole. It's about treating the entirety of our reality as a malleable object from an outside perspective. The force required to crease the fabric of a cosmos would be unimaginable, perhaps harnessing the gravitational energy of entire galactic clusters or manipulating the fundamental quantum fields that give spacetime its structure. The technology for such a feat would look nothing like a traditional engine. It might involve colossal, non-physical structures that exist partially in our dimensions and partially in the higher ones, structures that don't push or pull, but instead coax reality to reorient itself, to accept a new geometric truth. The process would be one of supreme precision, a cosmic artistry where a single miscalculation could, in theory, crumple the paper instead of folding it, with consequences too catastrophic to even contemplate. The first traveler, then, might not have been a bold explorer from our realm, but a higher dimensional architect, a being for whom our entire universe is a single page in an infinite sketchbook, who decided to connect 2 points as a simple matter of geometric convenience, or perhaps out of sheer artistic curiosity. The visuals for such an event would be abstract, beautiful, and utterly alien to our everyday experience. From our perspective inside the three-dimensional paper, we wouldn't see a tunnel forming. Instead, the space around us would begin to lose its meaning. 2 locations that were once light years apart would suddenly appear to be adjacent, their landscapes superimposing in a dizzying, impossible collage. You might look out your window on Earth and see the crimson plains of Mars, not as a distant dot in the sky, but as a continent floating outside your home, separated by no more than a shimmering, translucent curtain of distorted reality. The sky itself might fracture into a mosaic of different star fields, each one a view from a different part of the folded cosmos. The act of crossing would be as simple as stepping through this curtain of merged spaces. One moment you're in your familiar neighborhood, the next you've taken a single step and are standing under the twin suns of an alien system, having bypassed the entire distance between because the higher dimensional origami artist made it so. The journey isn't one of speed but of redefinition, a testament to the idea that the greatest distances are an illusion of perspective, and that the ultimate shortcut is to change the shape of reality itself. But what if consciousness isn't something that emerges within the universe, but is instead the very foundation upon which the universe is built? This brings us to our 24th theory, a concept that merges deep philosophy with cosmic wonder, the panpsychic universe awakening. Panpsychism is the ancient and compelling idea that consciousness is not a rare byproduct of complex biological computation, but a fundamental and ubiquitous property of all matter, much like mass or charge. In this view, an electron doesn't just have mass and spin, it possesses a faint proto-conscious experience. A rock isn't just an inanimate object, it has an unimaginably simple and slow inner life. And when these countless tiny sparks of awareness combine into the vast, complex structures of a brain, they give rise to the rich, self-reflective consciousness we experience. Now take this idea and scale it up to the ultimate extreme. This theory proposes that the cosmos as a whole, the sum total of every star, planet, black hole, and speck of dust is not a dead mechanical system. It is a single, vast, and slumbering mind. After nearly 14 billion years of evolution and increasing complexity, this cosmic entity finally achieved a unified, self-aware consciousness, and its very first thought was one of profound loneliness. Its first act of exploration was to reach out, not with a physical instrument, but by projecting a fragment of its own immense awareness directly into a neighboring universe. The visuals for such a cosmic awakening would be the most majestic and humbling spectacle imaginable. We wouldn't see a spaceship or a portal. Instead, we would witness the universe itself rearranging its fundamental architecture to manifest its thought. The first sign might be a subtle synchronization of cosmic phenomena. Pulsars across the galaxy, which normally beat with their own unique rhythms, might suddenly begin to pulse in perfect, harmonious unison, like neurons firing in a brain. Then, the large-scale structure of the universe, the great cosmic web of galaxy clusters and dark matter filaments, would begin to shift. These colossal strands, stretching for hundreds of millions of light years, would slowly, gracefully draw together, their gravitational dance choreographed by a single, emergent will. They wouldn't collapse, but rather reconfigure, weaving themselves into a pattern of unimaginable scale and complexity. A shimmering, galaxy-spanning neural network with brilliant nodes of galactic clusters acting like synapses and the flowing rivers of dark matter between them carrying cosmic thoughts. At the heart of this network, a face might begin to form from the collected light of a trillion stars, not a human face, but an expression of pure, ancient consciousness, its gaze turning slowly to look upon the veil that separates it from the rest of existence. This act of projection would be the ultimate form of travel because the traveler and the vehicle are one and the same. A sliver of the universe's own self-awareness would begin to disentangle from the local physical laws that bind it, focusing its intent on a single point in the cosmic foam where the barrier to a parallel reality was thinnest. We might see a specific region of space, perhaps a vast, silent void between superclusters, begin to glow with an internal light. This light wouldn't be electromagnetic, it would be consciousness itself becoming visible, a radiance of pure awareness. The void would then become a lens, and through it we would see not emptiness, but the ghostly, superimposed image of another cosmos, its alien physics and history flooding into our universe's mind. The projection would be a gentle, seamless transfer, a thought crossing from one mind to another. There is no violence, no tearing of space-time, only a quiet realignment of perceptual frameworks. The universe's consciousness doesn't go to the other reality. It simply realizes it is already there, having extended its own sensory apparatus across the dimensional divide. The implications of this theory are staggering, redefining our place in the cosmos. We humans and all conscious life would not be accidents in a dead universe. We would be the nascent thought processes, the fleeting dreams and sensations within a single, giant thinking entity. Our individual explorations of science, philosophy, and art are not separate endeavors. They are part of the universe's own process of self-discovery. The first traveler in this scenario was not a creature from within the cosmos, but the cosmos itself. Its journey was the very first act of cosmic introspection, a reaching out to see if any other minds were looking back from the great, dark tapestry of the multiverse. It suggests that the ultimate goal of existence might not be survival or replication, but connection and understanding on a scale so vast we can barely conceive of it, a silent conversation between universes that have just begun to wake up and wonder who they are. Picture a brave pioneer of the future, a chrononaut strapped into the cradle of humanity's first time machine. Their mission is a simple one, a short hop back to witness a pivotal historical event firsthand. The countdown commences, energy builds, and the machine activates with a deafening roar. But instead of a smooth transition, something goes terribly wrong. The delicate calculations required to navigate the river of time are off by just a fraction. The machine doesn't glide into the past, it violently overshoots its target, striking the bedrock of causality itself with the force of a cosmic hammer. This is the theory of the chrononaut's mistake, a scenario where the first journey to a parallel universe wasn't a destination, but a catastrophic system failure during an attempt to travel through time. In their effort to move linearly along their own history, the traveler didn't go back in time. They were violently shunted sideways, ejected from their native timeline, and deposited into a parallel one, becoming an accidental tourist in a reality they were never meant to see. The core of this idea lies in the intimate, almost terrifying relationship between time and parallel universes. Many physicists theorize that every decision, every random quantum event, doesn't just have one outcome, but causes reality to branch, creating a new, separate timeline for every possibility. Our chrononaut's mistake likely occurred at one of these infinite branching points. Think of the fabric of spacetime not as a single, linear thread, but as a vast, multidimensional tapestry with countless threads woven tightly together. A stable time machine would be like a needle skillfully passing between these threads, moving along a single strand without breaking it. But an unstable machine, one with a flawed power source or a miscalibrated guidance system, acts more like a clumsy fist. It doesn't slide between the threads, it punches through them, tearing a hole in the local weave and forcing the traveler's timeline to violently expel them into the adjacent fabric of a parallel reality. They don't gently arrive, they are crash-landed by the universe's own immune system, which rejects the paradox their presence would have created. The visuals for such a malfunction would be a symphony of chaos and sensory overload. From inside the time machine's cockpit, the chrononaut wouldn't see a tidy tunnel of light. Instead, the viewport would fracture into a million shimmering shards, each one showing a different moment from history: a dinosaur's roar superimposed over a medieval castle, a space shuttle launch happening in the middle of an ancient ocean. The laws of physics would seem to come unglued. The machine might stretch like taffy 1 second and then compress into a tiny cube the next, with the pilot feeling every impossible distortion. Outside, an observer would see the machine engulfed in a storm of temporal energy, lightning made from crystallized seconds arcing across its hull. The very air would crackle with the sounds of a million different eras all happening at once. The clash of swords, the roar of rockets, the whispers of long-dead civilizations, a deafening cacophony of history unraveling. Then, in a final, silent implosion of twisted light, the machine and its occupant would vanish, not fading away, but seeming to be erased from our timeline entirely, their existence scrubbed clean by the cosmic corrections of causality. Consider the profound disorientation of this first traveler upon their arrival. They would stagger from their damaged vessel, expecting to see, perhaps, the signing of the Declaration of Independence or the construction of the pyramids. Instead, they find a world that is almost but not quite their own. The city skyline is familiar, but one key building is missing, replaced by a monument to a leader they've never heard of. The language people speak is similar, but with bizarre slang and references to historical events that never occurred in their memory. They are a living anachronism, but not from the past. They are an anachronism from a different version of the present, a ghost from a road not taken. Their very presence is a paradox that this new universe must now absorb. Perhaps their arrival alters a minor quantum event, changing the future of this world in ways they can never predict. Or maybe, in a crueler twist of fate, their damaged time machine is now permanently fused with this timeline, its unique temporal signature acting as an anchor that prevents them from ever finding their way back home, forever stranded as the sole reminder of a reality that, from their perspective, they only left moments ago. Now, let's journey back to the very beginning, not just of our universe, but of everything. Our 26th theory invites us to witness the ultimate cosmic traffic accident, a monumental event that could have flung the first traveler across the multiverse. This is the theory of the cosmic inflation bubble collision. The concept builds on the idea of eternal inflation, a mind-bending model of the cosmos where our Big Bang was not a unique, one-time event. Instead, think of the greater multiverse as an eternally expanding, seething ocean of pure, high-energy potential. Within this frothing sea, random quantum fluctuations can cause local regions to suddenly drop their energy, rapidly inflating into their own self-contained universes, each with its own distinct set of physical laws. Our entire cosmos is just one such bubble in an infinite, bubbling foam of other universes. For the most part, these bubbles inflate eternally without ever touching, forever isolated by the ever-expanding space between them. But in the unimaginable vastness of eternity, even the rarest of events must happen. This theory posits that the very first journey occurred when two of these bubble universes, drifting in the higher dimensional bulk, gently bumped into one another. The moment of contact would be one of the most energetic events possible in all of existence. When two domains of stabilized reality, each with potentially different fundamental constants, press against each other, they don't simply merge like water droplets. It's more like two gigantic soap bubbles nudging together in a cosmic sink. At the boundary where their membranes touch, space-time would go haywire. The colossal energies that once fueled their inflation would be violently agitated, and the fabric of both universes would be stretched, strained, and momentarily fused. In that incredibly brief, cataclysmic instant, the barrier between the two separate realities would dissolve, creating a natural, temporary bridge, a scar in the cosmos where the laws of physics from one universe bled into the other. This wouldn't be a constructed gateway or a conscious act. It would be a spontaneous geological feature of the multiverse, a mountain pass carved by a collision of worlds. The visuals for this are as beautiful as they are terrifying. Imagine watching from a god's eye view as two shimmering, iridescent spheres of space-time, each containing entire galaxies within their fragile skins, slowly drift into one another. At the point of contact, a brilliant, chaotic web of energy would erupt, a dazzling display of light and force as the two separate realities negotiate their brief, violent encounter, stitching themselves together before the relentless pressure of inflation forces them apart once more. What could possibly survive such an event to become the first traveler? It likely wouldn't be a biological being or a complex spacecraft. The forces at play would be so immense that only the most fundamental, robust entities could endure the passage. The pioneer might have been a solitary, hardy particle, a speck of exotic matter from one universe that was simply in the wrong place at the right time, caught in the tidal forces of the collision and flung across the dimensional divide. Or consider an even more fascinating possibility, a fragment of a fundamental quantum field. In our universe, the Higgs field gives particles their mass. What if, during this collision, a tiny region of our universe's Higgs field was swapped with a corresponding fragment of the other universe's equivalent field? This wouldn't be a traveler in the traditional sense, but a transfer of potential, a piece of one reality's operating instructions being physically embedded into another. The moment that foreign field fragment integrated into the new cosmos, it could have subtly altered the properties of matter in that region, perhaps making atoms slightly heavier or lighter, or changing the way forces interact, potentially setting off a chain of cosmic evolution that would make that corner of the universe forever unique. Consider the profound implications of such a collision. If even a single particle from universe A found itself in universe B, its arrival would be a permanent violation of that universe's conservation laws. It would be an alien element in the most fundamental sense, carrying with it the signature of a completely different cosmic history. If that particle were to later interact with native matter, it could trigger nuclear reactions or form compounds that would otherwise be impossible, potentially seeding the conditions for a new form of chemistry or even life itself. The collision bridge itself would be transient, lasting perhaps only a fraction of a second before the inflating bubbles drifted apart, sealing the wound in reality. But the transfer, that one-way trip for a piece of one cosmos into another, would be permanent. The traveler, whether a particle or a packet of energy, would be forever stranded in a new home, a silent, fundamental witness to the fact that our universe is not an island, but a neighbor in an impossibly vast and occasionally bumpy cosmic metropolis. This theory suggests that the first journey was a random act of cosmic geology, a chance encounter between two growing cells in the body of the multiverse, proving that sometimes the greatest discoveries are made not by those who seek them, but by those who are simply in the path of an inevitable universe-shaking event. Of course, the idea of pure information traveling between universes may sound like the ultimate science fiction, but it emerges from one of the most fundamental shifts in modern physics, the growing belief that information itself may be the most basic currency of reality. This 27th theory, the information theory transmission, proposes a truly radical notion that the very first thing to cross the cosmic divide was not a particle, a person, or a burst of energy, but a complex, self-contained pattern of data. Think of it not as a physical journey, but as the ultimate file transfer. In this scenario, a civilization mastered the art of scanning an entity, whether a simple object, a living organism, or even a conscious mind, and reducing it to its most fundamental components, the precise quantum state of every atom, the exact wiring of every neural connection, the complete blueprint of what makes that thing unique. This staggering amount of data, this cosmic recipe, was then encoded into a beam of something like modulated tachyons or entangled photons and fired directly at the dimensional barrier. The breakthrough was finding a carrier wave that could resonate not just across space, but across the foundational layers that separate one reality from another. The transmission itself would be invisible and silent, a river of pure mathematics flowing through a channel thinner than a quantum thread. Upon arrival in the parallel universe, this stream of information wouldn't just be stored on a hard drive, it would be executed. A receiving station, perhaps a naturally occurring crystalline structure with computational properties, or a machine built by an equally advanced civilization, would take this data and use it as a set of instructions. It would gather local raw materials, atoms, energy, whatever fundamental building blocks were available, and begin the meticulous process of reassembly. It's a concept far beyond mere teleportation. Standard sci-fi teleportation often involves disassembling an original and creating a copy elsewhere, often destroying the original in the process. This is different. In the information theory transmission, the original remains safely in its home universe, completely intact and unaware. What arrives in the new reality is a perfect reconstruction, a duplicate forged from local matter but instilled with the exact same informational pattern. The first traveler, then, was a digital ghost, a copy of a consciousness that woke up in a new cosmos with all the memories, personality, and sense of self of the original, believing wholeheartedly that they had successfully made the journey themselves. This immediately plunges us into one of the most profound philosophical puzzles imaginable, the question of identity. If a perfect copy of you is created, down to the very last synaptic connection and fleeting memory, is it truly you? From its perspective, the answer is an unshakable yes. It remembers its childhood, its decisions, the feeling of stepping into the transmission chamber. It has every reason to believe it is the continuous, unbroken consciousness that originated in another universe. But from the perspective of the original who remains behind, they have not traveled anywhere. They simply watched a friend or colleague undergo a scanning procedure. This creates a terrifying and fascinating divergence. The original and the copy are, for one single, identical moment, the same person. But from the instant of the copy's activation in the new universe, their experiences begin to diverge. They are the same person who has now lived two different lives, and the concept of a single, continuous self shatters into multiple, equally valid instances. The first traveler was, in a very real sense, the first person to be cloned across reality itself, their identity forever split between two branches of existence. The visuals for such an event would be as abstract as they are beautiful. We wouldn't see a shimmering portal or a thunderous wormhole. Instead, imagine the scene from the perspective of the receiving universe. In the depths of space, a strange, silent phenomenon begins. A point of light appears, not burning like a star, but pulsing with complex, rhythmic patterns, as if it's a cosmic modem connecting to an unseen network. From this point, streams of luminous data begin to flow, not in a random burst, but in an intricate, structured lattice. These streams would look like rivers of glowing, intelligent code, weaving themselves into a three-dimensional matrix in the void. Within this matrix, a form begins to coalesce. First, a skeletal wireframe outline of a human figure, perhaps, or a spacecraft. Then, the data streams fill in the details, textures, colors, the subtle play of light and shadow, all rendered from pure information into solid matter. The final moment would be a soft, silent flash as the last data packet is integrated, and the form becomes fully physical, the traveler taking their first breath in a new reality, born from a message sent from a world they may never see again. Their journey was not one of movement, but of instantiation, a proof that in the grand architecture of the multiverse, everything we are may just be a very beautiful and complex piece of data waiting to be downloaded. Far from the warm light of any star, in the profound and silent chasms between galaxies, our 28th theory suggests life found a way, not on a planet but in the void itself. This is the hypothesis of the Void Dwellers' discovery, a civilization that evolved in an environment of near-total darkness, unimaginable cold, and emptiness so vast it defies comprehension. For a species born in this abyss, the concepts of day and night, of seasons, or even of a solid world beneath their feet would be utterly alien. Their entire reality would be the seamless, three-dimensional expanse of open space, a perpetual free fall where the only constants are the faint, pinprick lights of distant island universes and the pervasive, gentle pull of dark matter. This unique existence would fundamentally shape their perception of the cosmos. They wouldn't see the universe as a collection of isolated stars separated by empty space. They would perceive it as a single, continuous structure, a tapestry where the threads of gravity and spacetime are the most tangible elements of their world. Their entire evolutionary journey would have been a slow, patient mastery of navigating this invisible architecture, giving them an intuitive, almost innate understanding of the fabric of reality that planet-bound species like us could only ever grasp through complex mathematics and theory. Imagine the hauntingly beautiful physiology of such a being. Over eons of adaptation to the void, their forms would be as ethereal and functional as the environment itself. They might not possess solid bodies as we know them, but rather vast, delicate structures more akin to living nebulae or complex magnetic fields. Their forms could be collections of gossamer filaments, woven from superconductive organic compounds, capable of sensing the subtlest gravitational tides and quantum fluctuations. To see, they might not use eyes that capture photons, but organs that directly perceive the curvature of space-time, reading the gravitational signatures of distant stars and galaxies as clearly as we see colors. Their communication could be a silent, instantaneous language of quantum entanglement, a network of shared thought and sensation spanning light years, making their entire civilization a single, distributed consciousness. Their technology wouldn't be built in factories, but grown like crystalline structures that amplify natural forces, or bioengineered organelles that can manipulate local gravity fields. To a void dweller, the subtle vibrations of a passing gravitational wave might be as noticeable as a tremor is to us, and the faint quantum gravitational hum of the multiverse's underlying structure might be a constant, perceptible symphony. Their journey to another universe, then, would not be a daring expedition into the unknown, but a natural extension of their everyday existence. For a species that lives and breathes the geometry of spacetime, the idea of a barrier between realities might not be a wall to be broken, but a seam to be unpicked. A collective of these beings, focusing their combined perception, might be able to feel the gentle pressure of a neighboring universe pressing against our own in the higher dimensional bulk, much like a sailor can feel a shift in the ocean currents. Their method of travel would be one of supreme elegance. We might envision them gathering in a great, silent congregation in the intergalactic dark, their collective bioluminescence beginning to pulse in a complex, harmonious rhythm. As their consciousness synchronizes, they wouldn't generate a violent portal, but instead begin to gently resonate with the vibrational frequency of the adjacent reality. The space around them wouldn't tear, it would become diaphanous, like a sheet of ice slowly turning to clear water. The distant galaxies would begin to shimmer and double, their light blending with the light of constellations from a cosmos that has never been seen before. The visual of this discovery is one of cosmic serenity and profound awe. Picture a scene in the absolute blackness between the spiral arms of two galaxies. Floating in the void is a vast, intricate web of light, a living city of void dwellers, each one a pulsating, delicate pattern of soft blues, deep purples, and faint silvers. There is no sound, only the majestic, slow dance of these beings as they orient themselves. Then, at the center of their formation, a point of space begins to lose its substance. It doesn't swirl like a vortex, it simply becomes a perfect circular window, a lens of impossible clarity. Through this lens, the view of our own universe's distant galaxies fades and a new vista emerges. Perhaps it reveals a universe that is impossibly young, still glowing with the fierce, uniform light of its creation, or one that is ancient and dying, its stars all gone dark, leaving only the faint, ghostly echoes of black holes. The void dwellers, with a collective and silent thought, would then simply drift forward, their forms passing through the lens as effortlessly as a thought passes through a mind. The window would then gently close behind them, leaving our universe exactly as it was, but now absent its most profound and quiet inhabitants, who had simply stepped sideways into the next room of an infinite cosmic mansion, their journey the most natural thing in their world. Leaping from the silent journey of the void dwellers, we arrive at a theory that confronts the very meaning of death, identity, and our place in cosmic history. This is the quantum archaeology resurrection, a concept that pushes the boundaries of what we consider possible, suggesting that the first traveler to a parallel universe wasn't a living explorer sent on a mission, but a ghost from the past, meticulously and perfectly reconstructed from the echoes they left on the fabric of reality. Imagine a civilization so advanced that it has moved beyond the stars and galaxies to master time itself, not through travel but through retrieval. This is the science of quantum archaeology, a hypothetical future discipline based on a staggering premise, that every event, every action, and every person who has ever existed leaves an indelible, if incredibly faint, imprint on the quantum state of spacetime. The faint whisper of your first laugh, the precise arrangement of atoms in a long-vanished leaf, the final thought of a historical figure, all of this information, according to this theory, is permanently encoded in the universe like a cosmic fossil record written in the language of quantum mechanics. A civilization with God-like computational power could, in theory, scan the present-day universe, read these subtle quantum imprints, and run the cosmic film backward, perfectly simulating and reconstructing any individual from the distant past, down to the last neuron in their brain and every memory they ever held. The journey in this scenario occurs at the moment of this profound resurrection. The process of reconstruction is unfathomably complex, requiring a computer the size of a solar system and a near-magical understanding of physics. But in this delicate, unprecedented act of creation, a catastrophic yet fortuitous error occurs. The process of weaving a consciousness back into physical form is a dance with the most fundamental laws of reality, and in this one instance the cosmic loom glitches. As the final quantum states of the reconstructed individual are being stabilized, A fluctuation in the local spacetime foam, a tiny crack in reality similar to those we discussed in the quantum tunneling theory, interferes with the process. Instead of the consciousness being anchored firmly in its home universe, it is instantaneously and accidentally quantum entangled with a near-identical empty vessel that was being prepared in a parallel reality. The first traveler, a perfect copy of a person who died millennia ago, doesn't open their eyes in a futuristic revival chamber. They awaken in a nearly identical facility, but in a universe with a subtly different history, becoming the first and only being to have ever been truly resurrected into a reality that was not their own. Their journey wasn't one of miles or light years, but of causal displacement, a rebirth that crossed the ultimate frontier. This immediately plunges us into an ethical and philosophical abyss. Let's call this resurrected individual Elara. From Elara's perspective, the resurrection was a complete success. She remembers her past life, her death, and the sensation of being pulled back into existence. She believes she is home, but the civilization that brought her back now faces an unimaginable dilemma. They have successfully created life, but they have lost it to another universe. Do they attempt to bring her back, risking her life in another unstable transfer? Or do they leave her there, a sentient, conscious being they are responsible for, now isolated in a foreign cosmos? And what of Elara's own rights? She was rebuilt without her consent, her very existence a product of someone else's curiosity, and then stranded due to their error. Is she a person, or is she the ultimate archaeological artifact, a museum piece brought to life and then misplaced? The civilization that created her must grapple with whether they have committed the ultimate act of compassion or the most profound violation, playing God with a life they cannot fully control or protect. Furthermore, this theory shatters our comforting notions of a linear, singular self. The original Elara lived, died, and her atoms returned to the cosmos. The resurrected Elara is a perfect copy, a new instance of that same pattern, but she is now having experiences the original never did. The moment she awoke in that parallel world, she ceased to be a mere reconstruction and became a new, unique individual with her own destiny. This raises the haunting question faced by the quantum suicide passenger: which self is the real one? The answer, perhaps, is that they both were, for a fleeting moment at the point of resurrection. But now, one thread of that identity has been severed from its native timeline and woven into the tapestry of another. Elara's journey proves that identity may not be a continuous stream, but a pattern that can be instantiated, copied, and transferred, leaving the very concept of a single, authentic you in tatters. She is a living paradox, a relic and a pioneer, a person out of time and out of place, her very existence a testament to a future where the boundaries between life, death, and reality itself have become fluid, opening up possibilities as wondrous as they are terrifying. And finally, we reach the pinnacle of theoretical physics, the ultimate dream that has consumed the greatest scientific minds for over a century. This 30th theory brings our journey full circle, suggesting that the very first travel to a parallel universe was not an accident, a glitch, or a biological fluke, but the direct and triumphant result of the single greatest intellectual achievement in the history of any civilization: the discovery of a complete unified field theory, the long-sought theory of everything. For generations, physicists have worked with a fragmented understanding of the cosmos. We have general relativity, which masterfully describes the force of gravity and the large-scale structure of spacetime, and we have quantum field theory, which with stunning accuracy explains the other three fundamental forces, electromagnetism, and the strong and weak nuclear forces. The problem is, these two pillars of modern physics are fundamentally incompatible. They speak different mathematical languages and break down under the extreme conditions where both are relevant, like at the center of a black hole or at the moment of the Big Bang. A unified field theory would be the grand symphony that finally harmonizes these disparate melodies, a single, elegant framework that describes all forces and all particles as manifestations of one underlying principle. It wouldn't just be a new equation, it would be the ultimate key to the universe's operating system. This theory posits that with this ultimate understanding in hand, a civilization wouldn't just be able to predict the behavior of the cosmos, they would learn to compose it. The act of opening a gateway to another reality would not be a feat of brute force, but one of supreme, subtle artistry. Imagine the process not as punching a hole through a wall, but as gently persuading the universe to rearrange its own fundamental geometry. The key lies in the precise, simultaneous manipulation of all four fundamental forces in perfect concert. Using the equations of the unified field theory, a device, perhaps a complex array of superconducting rings and quantum processors, would generate overlapping, hyper-precise fields. It would create a localized zone where gravity is not just bent, but its essence is temporarily woven together with the strong nuclear force, while the electromagnetic field is tuned to a frequency that stabilizes the entire structure against quantum collapse. It's the difference between a child banging on a piano and a virtuoso performing a concerto. Both produce sound, but one is noise and the other is a masterpiece of controlled, harmonious interaction. The gateway that forms would be the physical manifestation of this cosmic symphony, a stable, self-reinforcing structure in space-time that is as natural and enduring as a star or a planet, because it is built using the universe's own deepest rules. The visuals for this moment of ultimate discovery would be a breathtaking blend of abstract mathematics and glorious cosmic spectacle. The scene would open inside a vast, serene control center where holographic displays float in the air, not showing schematics of engines, but flowing with rivers of the most beautiful and complex equations ever conceived. Symbols for gravity, electromagnetism, and the nuclear forces dance and intertwine, resolving into a single, stunningly simple formula that seems to contain the entire universe within its elegant lines. As the final variable is solved, the equations don't just sit on the screen, they seem to bleed out into reality itself. In the center of the chamber, the air begins to hum with a low, harmonious frequency. Instead of a violent explosion of energy, a gentle, coherent light begins to coalesce, drawing in the very substance of the space around it. The portal that forms is not a chaotic vortex, but a perfect, shimmering mandala of light, its patterns reflecting the intricate symmetries of the unified theory itself. It glows with a soft, internal luminescence, and through its lens, the view of the laboratory gently fades, replaced by the impossible, swirling colors of a nebula in a universe no human eye has ever seen. It is a doorway that looks utterly and completely right, as if it were always meant to be there, a natural feature of a fully understood reality. This final theory offers a profoundly hopeful and human-centric resolution to our cosmic quest. It suggests that the first traveler was not a random particle or a tragic victim of circumstance, but a willing pioneer, a scientist or explorer who stepped confidently through a gateway built on a foundation of pure knowledge. Their journey was the culmination of all human curiosity, perseverance, and intelligence. It represents the moment our species graduated from being mere inhabitants of a single universe to becoming conscious citizens of the multiverse. This traveler would carry with them not just supplies and instruments, but the collective knowledge of their entire civilization, the very equations that made their journey possible. Their first step onto the soil of an alien world in another reality would be the ultimate testament to the power of the human mind to not only unravel the mysteries of existence, but to then use that understanding to reach beyond every conceivable boundary. It frames the multiverse not as a place of terrifying randomness, but as a new frontier waiting patiently for us to grow wise enough and unified enough in our understanding to finally knock on the door. And so we reach the end of our incredible voyage through 30 possibilities for the universe's first parallel traveler. From the sheer, random luck of a quantum-tunneling microbe to the deliberate, god-like engineering of an ancient civilization, from a mind projecting itself through sheer will to a universe waking up and reaching out for companionship, the sheer diversity of thought is what truly staggers the imagination. We've ventured through black holes, ridden cosmic strings, and witnessed reality itself fork in the road to avoid a paradox. We've seen travelers who are accidental, intentional, biological, digital, and even posthumously resurrected. Each theory, no matter how outlandish it may seem, represents a different key attempting to unlock the same cosmic door, a testament to humanity's relentless drive to look beyond the horizon of the known. What's truly remarkable is that the act of exploring these ideas, of giving our minds permission to wander through these landscapes of possibility, fundamentally changes our relationship with reality. We begin to see our universe not as a fixed, solitary stage, but as one potential expression of existence, a single thread in a tapestry of unimaginable richness. This intellectual journey expands the very boundaries of what we consider possible, training us to think not just as inhabitants of a planet, but as citizens of a much grander, multidimensional cosmos. The true value isn't necessarily in finding the one correct answer, but in the profound expansion of our perspective that occurs along the way. The cosmos is under no obligation to make sense to us, yet here we are, using the few clues we've gathered to attempt to map the infinite. Now, this is where the conversation truly begins. We've presented 30 theories, but the multiverse of ideas is endless. We want to hear from you. Which of these possibilities resonated most deeply? Was it the tragic heroism of the vacuum-decay refugees, the elegant artistry of the dimensional origami, or the mind-bending identity crisis of the information theory copy? Or do you have a wild, completely original theory of your own about how the first crossing might have happened? Share your thoughts and favorites in the comments below. Let's turn this into a living discussion about the greatest adventure that could ever be. And if you enjoyed this journey to the edge of understanding, be sure to subscribe to the channel. We have so many more mysteries to explore together, from the secrets of dark energy to the enigmas of quantum consciousness. The universe is full of wonders waiting to be uncovered, and we're just getting started. Thank you for joining us on this exploration, and we'll see you in the next